So today's topic is D'Alembert's principle. So first we'll understand what this theorem is telling us. So this principle states that if a rigid body is acted upon by a system of forces, then the system may be reduced to a single resultant force whose magnitude, direction and line of action may be found out by the method of graphic statics. So we'll first understand what this theorem is telling us. Suppose this is a rigid body. Suppose it is several forces are acting on it. Suppose the forces F1, F2, F3, F4 are acting on it. So what this theorem is telling us, so all these forces can be reduced to a single resultant force. So here all the forces will help in accelerating the body. Because of all these forces, the body will move a little. Suppose there is one force acting in the opposite direction also, F5, F6. So F1, F2, F3, F4 are helping in accelerating the body in forward direction. So they are trying to push the body, and F5, F6 are helping to deaccelerating the body. So there will be a net equivalent acceleration by which body will move, either depending on the magnitude. So either it will move in this direction or it will move in this direction. Suppose it is moving in this direction. So we know that from the Newton's second law, force equal to mass into acceleration. So all these forces will reduce to an equivalent force according to D'Alembert, so which is known as inertia force. So we can write it summation of force equal to mass into acceleration. So we can replace all the forces by single equivalent force, which is known as inertia force. So this is the D'Alembert's principle. So I'll further give one example. Suppose this is a body, a block is resting over it. Suppose this side I am applying force of 150 Newton, and from the other side one is applying force of suppose 50 Newton, and the mass of the body is suppose 5 kg. So we can find out the acceleration using D'Alembert's principle. So this force is trying to accelerate body in this direction, and this 50 Newton is trying to accelerate the body in this direction. So what will be the net force? So how net force equal to inertia force, that is product of mass into acceleration. So what is how we will take the sign convention? So in the direction in which the body is going to accelerate, the force which are acting in that direction will take it as positive. So obviously 150 Newton is greater than 50 Newton, the body will accelerate in this direction. So 150 Newton is acting in the direction of acceleration, so we will take that as positive. And the 50 Newton is acting opposite to the direction of acceleration, so we will take it as negative. So 100 equal to 5 into acceleration. So what is acceleration? So yeah, 100 equal to 5 into acceleration, 100 by 5, 20 meter per second square. So we can solve all the forces like this, and we can find out the value of acceleration or any other force if it is required, it is asked in the question. So now I think you all are clear about D'Alembert's principle. Now we will move to Newton's third law. So here you can see this is Newton's third law of motion. So I think you all have read in the school also what is Newton's third law. Each action has equal and opposite reaction. So if I'll slap you, then obviously my hand will also get hurt. So this is Newton's third law. If I will apply some force, then there will be some reactive force. So we'll go to the application of Newton's third law. So what is the application of Newton's third law? You can see recoil of gun. So this is the application of Newton's third law. Next we'll move to the application of Newton's third law. So what Newton's third law states, each action has equal and opposite reaction. So first one is the recoil of gun. So this is one application of Newton's third law. It also tells about the conservation of momentum. So when the shooter fires a bullet, so the bullet moves forward with some velocity, but it applies some reactive force. Because of the reactive force, the gun always move little backward. So it always so because of that, the shoulder of that shooter gets hurt. So this is the application of Newton's third law. So we'll find out with what velocity that the bullet will move, or with what velocity the gun will move backward. So we'll find out from the conservation of momentum. So let capital M equal to mass of the gun, and capital V velocity of the gun with which it recoils, and small m is the mass of the bullet, and small v the velocity of the bullet after explosion. So momentum of the bullet after explosion is mass of the bullet and velocity of bullet after explosion, and momentum of the gun is mass of the gun and velocity of the gun with which it recoils, with which it moves backward. So after balancing the momentum, so momentum of the bullet after explosion equal to the momentum of the gun. So from that, if we know the mass of the gun and mass of the bullet, and velocity of one of the thing, then we can find out the velocity of other. So this is one important topic for your examination. I've seen most of the time question comes from this topic, so you should practice the questions from the recoil of gun topic. So we'll solve problems related to this. So let's solve some problem. So the question is, a machine gun of mass 25 kg fires from a bullet of mass 30 kg with a velocity 250 meter per second. Find the velocity with which the machine gun will recoil. So it is given capital M, that is mass of the gun is 25 kg, mass of the bullet small m is 30 gram, and velocity of the firing, that is velocity at which the bullet moves, is 250 meter per second. So from the conservation of momentum, we can find out the velocity at which the gun recoils. So after solving, we got that velocity is 0.3 meter per second. That is capital V. Sorry, in this here I have written it small v, but it is capital V. We found out that velocity at which the gun recoils is 0.3 meter per second. Next, we'll move to another question.